All right, and welcome back. As you can recall from what we've been focusing on this chapter thus far, we're talking about solving equations. We've talked about solving rational equations. We've talked about solving quadratic equations. We've talked about solving radical equations. We're going to change gears just a little bit, and we're going to start talking about linear inequalities. And, I don't think this is necessarily something that we need to talk about, but we got all the symbols over here that we need to make sure that we understand what they read as. So our first symbol is we have less than. One thing that I want to recall for you is that we always read these left to right. So then we have greater than. And then we have less than or equal to. And then finally we have greater than or equal to. That's not necessarily something that we needed to talk about, but it's important to always recap. Now, I took this next visual out from the textbook because I want to talk about the notation. The main notation that we're going to be using throughout really all of your math classes are interval notation. And you can see that there's all these different inequality examples here. And the big thing that I want to talk about is the use of parenthesis versus bracket. And it's easier to start with bracket. We use bracket when the values are included in the response. Now, if you notice here, here's a bracket, right? And the reason why we're using a bracket on that A is because it said it was greater than or equal to. Now, notice I have to read right to left because I start with where the X is, and then I read towards the A. So X is greater than or equal to. That means A is a part of that set. So we're going to use a bracket. So anytime we see less than or equal to, or in the other case of greater than or equal to, we're going to use the brackets. Up here with parentheses, we use parentheses when we get close to the value, but not actually included. And that would be dealing with just our less than or greater than symbols. Brackets when it's less than or equal to, or greater than or equal to. Parentheses when we're dealing with less than or greater than. Infinity is something that's always going to be assigned with parentheses. And the reason for that is because infinity is not actually a number, it's an idea, it's a concept. And we can get close to infinity, but then I could just say, well, it's infinity plus another one. I can just keep going. So there isn't a set ending point. So we need to use parentheses because it keeps on going even though we don't have a number to express there. So if I take a look at a couple examples here, this first one says x is less than or equal to 5. I want to first think about this visually. Here's 5. Because it says it's less than or equal to, we're going to include the 5 and then everything below it or everything under it. So my interval notation, or IN as I'm going to abbreviate, would be, well, it keeps on going left, so that's negative infinity, and it goes all the way up to 5, and 5 is included. So my interval notation would be parentheses negative infinity, comma, 5. In this next example, I always start reading from the x. So here I have x is greater than negative 2, and then I have x is less than or equal to 8. If I think visually for a moment, here's negative 2, here's positive 8. Since it's not or equal to on the negative 2, I'm going to have an open circle. And since it's less than or equal to on the 8, I'm going to have a closed circle. And it's going to be everything in between those two. That leaves me with my interval notation of parenthesis negative 2 to 8 with a bracket. I'm getting close to the negative 2, but not actually negative 2. And I'm getting all the way up to 8 itself. A special note that I want to leave with you, always write the smaller number first. So just like a number line, all the negative numbers are to the left, all the positive numbers are to the right. It goes from less to big. Same way when we're writing interval notation. We want the smaller numbers on the left, and we want the larger numbers on the right. So that leads us to our next part, which is intersection versus union. The intersection refers to what do they have in common, whereas the union is what is their addition together. So here's my example. I'm talking about vending machines. So vending machine 1 has Coke, Sprite, Dr. Pepper, Barks. Vending machine number 2 is Pepsi, Mountain Dew, Sierra Mist, and Dr. Pepper. So the intersection of those two sets would be what do they have in common? The only thing that they have in common in these vending machines is a Dr. Pepper. So my intersection would be the set of just Dr. Pepper. Now with union, that would be everything. So that means I got Coke, means I got Pepsi, means I got Sprite, I got Sierra Mist, I got Dr. Pepper, I got Barks, and I got Mountain Dew. Recognize for a moment that I only wrote Dr. Pepper once. It was in both sets, and the union just needs it represented one time. Now let's apply this to two sets of numbers. So here, I have negative 5 to 11. So I would have a bracket on 5 and a parenthesis on 11. And my other set would be 4 to 18. A parenthesis on 4 and a bracket on 18. Here, we're talking about the intersection. So the intersection is what they have in common. Well, that would be this region right here. That's what they have in common. So I would write that intersection as parenthesis 4, comma 11 parenthesis. Whereas in the union, it's the addition of those two sets. That would leave me with bracket negative 5, comma 18 bracket. Our final point here is we're going to talk about solving inequalities, and there's just two quick rules that I want to recall for you. First rule, treat as if you solved an equation. So same rules as what you would do on a regular equation. Second rule, switch the inequality sign when multiplying or dividing by a negative number. So in this example, I'm just going to do my normal steps. I'm going to bring over this 4x. I'm going to bring over this 23. I'm left with 3x is less than negative 17. I'm dividing by a positive number. So I get x is less than negative 17 thirds, which in interval notation would be negative infinity to negative 17 thirds with a parenthesis. So that's any number that's under negative 17 thirds to negative infinity. Now here in this last example, I want you to notice that I have divided this middle term by 9. I can solve both sides simultaneous, but what I do to one side, I got to do to the other side. Before I can do any of that, I'm going to multiply everything by 9. So divide by, or multiply by 9, multiply by 9, multiply by 9. Leaves me with negative 27 less than or equal to 4x minus 7 less than 63. My approach to solving this now is I'm going to add 7 everywhere. So that's negative 20, 4x, 70. Divide everything by 4. Dividing by a positive number, so none of my symbols will change. Uh, 70/4 doesn't go in evenly, so I'm just going to leave it as 35 halves. So x is greater than or equal to negative 5. X is less than 35 halves. That's going to leave my interval notation as bracket negative 5, comma, 35 halves, parenthesis. So it's everything in between, including negative 5, but not including 35 halves. So there you have it. Use these notes as a reference as you start to prepare for your Chapter 1 test, and good luck.